All right, this is a video that I've wanted to do for some time, but I haven't found the right reason to not make it 100% controversial. So instead of just doing a software-defined radio-focused video, this is now going to be an SDR and a 3D printed CAD-related video. So let's get going here. So why? What is the reason for the video? Well, this is the reason right here. Bought a few of these a couple of years ago, probably on eBay. I think I bought these. From a specification perspective, you have a USB-C interface, and then you'll notice that you have 5 SMA ports, which are for this is receive only. And this board has a lot of controversy behind it. And so this all started going back to the SDR Play. This is the SDR Play RSP1. Normally it comes with a SMA connector, but I replaced mine with an N connector, which is a separate conversation altogether. But basically, this is the same, minus a few things, as this. And so this board, somebody released the design freely on the internet, and then somebody in a particular country copied it, and then they took a copy of that, of the schematic, and then used it as part of an academic project. And so I think while it started life in the best way possible, it has developed a little bit of a cult level of annoyance, which I agree with and I'll get into in a second. But in order to simplify the costs of this, when this was still in academia, I believe what happened was they designed this as a teaching tool. And so the reason why there's 5 antenna ports is that this proved a great way to show about bandpass filters. And so each of these strings of, let's see if I can get up in here. Yeah, you can't really see it too well. But there's a row of inductors and capacitors in here, which forms an LC network known as a bandpass filter. So each of these ports can only receive signals between the parameters of the bandpass filter. So this top port will go from 120 to 250 megahertz, 250 to 1000, 50 to 120, 30 to 60, and 0 to 30 megahertz. And so each of these ports, I see a value of this. You know, again, I think this was meant as like a teaching tool, but there's actually a great reason to have separate antenna ports for different frequencies, because if you have a radio covering 0 to 1000 megahertz, there's not going to be one antenna that does all of that well. But if you have 5 antenna ports, that means that it's pushing you as the end user to have purpose-specific antennas for those spectrum, and then you don't have to worry about some complications within software to enable different switches controlled in software, or even in some cases have like a hardware switch. So in this case, they reduced the cost in this design, and that's where part of the controversy comes from. So the MSI 2500 chip is commonly available, as is all of the other parts on here. So if you wanted to go and design your own SDR, I'm sure you can source these components yourself. But the big controversy is that SDR Play has their own proprietary driver, and that's where there's kind of like a big no-no. And so this board requires the SDR Play proprietary driver to work within the Windows operating system. And when I bought these, you can just download the API driver and it worked fine with most software. Matter of fact, I think I did an old video on that. But fast forward to later versions, SDR Play knows that intellectual property is an important thing to defend, and I totally agree with that. And so what they've done is they've implemented some ways in the later versions of their drivers, past version 3.07, where if you try to plug in a non-genuine SDR Play product, it will not allow their drivers to recognize that. So I feel like that's like a smart thing that they did. And there's ways to work around that, and I'm not going to cover that because I believe in protecting intellectual property. But you know, if you did buy one of these, yes, it works. No, you just need to have the right software knowledge to get it to work. And I'm not encouraging people to buy this, but if you were looking for a board that had these bandpass filters and the ability to look at 10 megahertz of continuous spectrum compared to like one of these guys, the RTL-SDR, which is good for 3.2 megahertz of spectrum. You know, this is like an inexpensive upgrade, and you can find these online. Again, I'll let you go and do a search for these boards. Again, I'm not promoting that, but I'm using this as a reason to say I made a mistake. When I bought these, I didn't realize that what version I picked up did not come with a case. And so I thought today I'll go through some of my design tribulations as it relates to designing a case. In this case, I used Tinkercad and I 3D printed them. And so ultimately, I got a really nice design, and I'll share. Oh, there we go. So here's what I came up with. It's a two-part design, and I'll show you some of the tips and tricks in the 3D printing journey design process that made me go from a raw board to having a case for my multiple SDRs. So let's switch over to Tinkercad now. Turn off, there we go. All right, so having designed lots of things in CAD, I wanted to make sure that I took accurate measurements, and I didn't want to have as much waste in prototypes. So I really wanted to think about the board itself and what was going to be most complicated. And so as part of the design, I thought the thing that's probably going to be one of the two complications is the SMA connectors. And so when I took measurements with my caliper, I noticed that each of the SMA connectors was not 100% lined up. And again, this is pretty typical within any electronics design. Nothing's going to be within 0.0001 millimeters, right? You know, one or two of the ports are going to be slightly off, and so that's not a big deal. I just needed to make sure that I accommodated that in my design. So instead of making each of these holes like 6.5 millimeters, I made them 7. So this way it gave me enough slop between each of the different boards. So this way I can make one case and know that it's going to fit a multitude of boards. In my case, I have 4 of these, and so I was able to model this correctly, and this would save me a lot of hassle later on. So this was the first thing that I designed and printed, just to make sure that this was going to fit over all 5 of the SMA connectors. And so if you're new to 3D printing, here's how I did this. So I'm just going to click up here and show you that I used a feature called the hole tool. And so we used shapes. Let's see if I can show shape. So I created a rectangle. So here's the dimensions, 50 millimeters by 10 millimeters. And then here's the dimensions for the holes. So 7 millimeter round. And then all I had to do was space them on center. And so let's go here. And if you already know about 3D printing, you can skip ahead. But if you're curious as to how to do stuff, if you're new to 3D printing, you might pick some stuff up here. So all you do to start, you just drag over a rectangle. You could specify in your size. In this case, I know what I wanted to start with, 50 by 10 millimeters. I wanted to make this 2 millimeters tall. And so you can see that that is that. And then all I had to do was just use the circle tool. You could either use the hole or solid. It's all the same. See, like that. So you just make it to the dimensions that you want. You can make it more round. And then you just put in your dimensions like so. And then just, space them out. In this case, I needed to make sure that they were all roughly the same space on center. So I did that with a caliper and measured everything. And then I also used the ruler tool here. So I'll just clean this up a little bit. So I use the ruler tool to see the spacing. So you can see that each one is 7, and then from the edge I went 2.5 millimeters, and you can see how this is all lined up correctly. So I spent a little bit more time designing this to know that it was going to save me some grief and headache at a later time. So this was the first thing I printed, made sure that everything fit perfectly, and then I moved into the case, the design of the actual case itself, which is right here. And so when I designed things, I found it easier to do this in multiple pieces instead of trying to do it some other fancy way. So I'm just going to ungroup everything so you can see what I did. So you can see I have the SMA connector here, so it's just as simple as giving it a rotation and then just dragging it into place. So that's basically how that works. And then I use different colors for different parts just so I could visually contrast them as I'm fitting them together. So you have the bottom plate and the top plate, and then the two side pieces. And so, you know, pretty easy stuff. You have 50 millimeters by 83. The board itself is actually 80 millimeters, and I'll tell you why I had to add 3 millimeters later in the design process. But yeah, this should all be pretty self-explanatory. And if you're new to Tinkercad or CAD in general, I like using Snap to Grid. It lets you line things up really nice, so you make sure that all your edges are exact to where you need them. So again, pretty basic stuff if you're into CAD already, but don't overlook. You can do a lot of cool things within Tinkercad. And then the other thing that I needed to do was add in some indentions on the side. So the way that I thought about it was the board has a little bit of extra side, and I thought I could just get them to slide right in. And let's see if I could zoom in here. So I fit these little side rail pieces, and then what you'll notice is I don't have the side rails going 100% right to the front. The reason why is that I needed to actually have a little bit of space, so when the board slides in, this little gap has enough for the back end of the SMA connectors, and then it gives it enough friction for me to push the board up against it. And I didn't want to use screws and make a complicated case design like some of the ones that you can buy. So this is all a lot easier. And I actually had to print out a couple iterations just to get the spacing just right, but I think that was worth the time. So that's how the case came together. And then finally, I decided to use the text tool in Tinkercad to add labels, and then all I did was type it in and use whole instead of solid, so this way when it prints it's just negative space. I figured I'd just do this case in one color versus two, but hopefully this gives you an idea of nothing could wear off, and so I labeled everything correctly per the SMA ports. So yes, the frequencies don't go in order, but I think because there was more of a complication in the filters, that's why they had to flip the RF chains on the board. So this is correct. This top row should not be 250 to 1000. It is correct. It's 120 to 250, then 250 to 1000, then everything else goes in order. And then I figured while I'm doing it, I'll put USB-C here, and myself and Joe, amateur radio call sign NE2Z, we collaborated on a project called SigPi, which uses a Raspberry Pi with some fancy compilations for popular SDR and related apps for signal intelligence, such as SDR Angel. And so I figured, whatever, we'll brand it and make a case with SigPi project on it. So that is the case. So let me merge that back together. Group. All right. So that's all one piece now. I'll just rotate it back in here like that. So that was the next thing that I needed to print. And then the final piece is the end cap. And so this was a little complicated, but not too much. And so the nice thing with standards is the USB-C port is a standardized size. but I needed to actually make it a little bit bigger to adjust for some tolerances on the board and connectors. And so just to show you how I did this is I had to create a complicated shape, and that actually came in the form of 3 pieces. So I did the square rectangle tool here, and then I used the round roof piece, and so you could see that I built those together, merged them as a solid, and then I made it into a hole. And so that's how I got the dimensions. And let's see, if you're wondering the dimensions, I will show you the dimensions. So I went with 9 millimeters and 3¼ millimeters. The spec is actually a little less, but I made this intentionally a little larger to again adjust for some slop in the assembly of the case. And then you see I have the sidewalls, and these I actually started off shorter, but ultimately I decided to go a little longer. And I'll show you all the iterations, almost like Iron Man, Mark 1, Mark 2, Mark 3, for me to get everything just right. But you know, I think having a good process for design simplified the process. It only took me, you know, like an hour and a half to come up with all the iterations and design and stuff. So we're not talking a lot of time in here, but that's basically the design. And then a feature that I started to incorporate but decided against it was I thought maybe what I would do is connect everything together with a screw. So that's why I put these 2 holes in here, thinking that I'd slide the plate in to the case, which I'll show you. Let's see. Yeah, so we'll just rotate things around 180. Move this up here. So my thinking was maybe I would put some holes in the case and in this, and then use like a screw to hold them together. But I started to think that just is getting complicated. I think once I put the piece in here, I'm just going to glue it in. There's no reason to service the board itself, and so everything would just fit right in. And let's see if I can get it in here. And so one thing you'll notice is that I have a little extra space here on the side, and this is just due to tolerances for the different SDRs themselves. And so I added that in just so it can move around a little bit, since each one is slightly different. But overall, this I think came out pretty nice. And now let me show you the final product, as well as the 1, 2, 3, 4, 5 iterations that I have. So here was the first version. I pulled it off my print bed too quick because I didn't let it dry. But whatever. This was just meant as a test. And then I had to play around with the size of the USB. So this was actually a little too tight. So in the later version, I made that a little bit bigger. But you can see this is where we started with. So it's filament waste number 1. Then we go to filament waste number 2. This I just wanted to experiment with what it would look like. So I wanted to check and see, should I maybe go with the raised text? You can probably see that that's raised, or embedded. So I just wanted to kind of test that, and you can see here I have the early test with integrating in holes for the end plate, which I ended up not wanting to use. And then also learned in this iteration was the side rails. I had to change some of the spacing, so I was off by about 0.75 millimeters. So I raised that up a little bit in the next iteration. So this was waste number 2. Then we want to waste number 3. So this is where I learned to make this bottom piece. This was 10 millimeters. I ended up going with 15 on the final design, but otherwise this was just a blank case like that, and you can see how this just kind of slits right in there. And I wanted to reduce the give, so I shrunk that on the next version. So this is waste number 3, and then you'll notice that I did a little trimming with some cutters. So yeah, this was waste number 3. Then we have version 4A and 4B, which are identical. So this is the near final version. So you can see how I think this came out pretty nice. And this uses the, there we go. So this is the shorter side, right? So this works pretty good. I just really wanted to make sure that I got those side rails designed in there pretty nice. So that was these two, just to double check everything. And then finally, here's the final version. So came out nice with the embedded text. I did this at a smaller layer, knowing that it would take longer to print, but it came out pretty nice. I added USB-C as well as the project, SIGPI project that you saw in CAD. And then here's the extended piece. And there you go. So here's the final version with the board installed. And with the USB connectors, I had to also try a bunch of different cables just to make sure that everything was fine. And so everything seats in there pretty nicely. And again, the goal of this video was just to kind of take you through my thought process for the design of the case. I'm not encouraging people to buy this. Don't go online and buy this. I don't want to hear the complaints. If you buy it, you're on your own. You can find the drivers, but I will share the STL file. So if you want the file, I'll delete out SIGPI project on it if you want to use it your own. But hopefully you learned a little bit more today, and we'll catch you in the next video. Take care.